Reference angles. Look, I even put little pink things around it. Going like, man, it's reference angles. Yes. Well, they're important. This is going to make your life easier. Spend a little time understanding this. Shit. Makes everything easier. Dude, I have no memory. Your teacher's memory sucks. I don't know if it's the drugs when I was younger, the drugs when I was a little older. Maybe I'm just getting old. Maybe I just have a shitty memory, but I don't have much of a memory. But I can do trig because there's patterns to it. And I only have to memorize about 5 or 6 different numbers and then just learn how to play some games. So hey, maybe you got a burnt out brain like me. Maybe I can show you some tricks that work. And maybe you got a badass brain that you want to just use, you want to keep some more storage in your hard drive for other things. Well, that's what reference angles are all about. We can shortcut things, we don't have to memorize them. Okay. I'm going to go back to this little thing I got drawn up with these common angles that we should know. And I'm just going to start describing what a reference angle might be. I'm not giving you the exact, go look in the book. Go look in the text or, hit ebook and go take a look. It'll give you the exact definition. But I'm going to put it in like this. That I call it alpha. Oh, by the way, they're going to call it theta prime in your text and on WebAssign. Sorry, I'm just not going to write like that. I'm going to use the old Jesus fish. I'm going for alpha. I'm going alpha. You know what I mean? It's solid. It's powerful. And it's also just confusing with that little prime thing on top of it. It gets you ready for calculus, but I would reserve that for a very different meaning. So I'm going to go with alpha. So that will be the difference between what I'm writing and what you might see in your homework or in the text. And alpha, if alpha is a reference angle, and this is just your teacher's definition. As a reference angle is I'm going to put this in the distance in quotes to the x-axis. Now this is wrong. This is just your teacher telling you kind of like how he looks at this. Now distance, well, I'm saying the distance in degrees, but this is not distance. Do you know that degrees are not a freaking distance at all? But what I'm saying here, when I'm saying the distance, I'm saying, hey, how far is it to get back down to the x-axis from 150? How far is it from 150 to 180? How far is that? That's 30 degrees. That's the distance I'm talking about. Degrees are not an effing distance. Please don't confuse that they are just because I'm writing it. Sorry about the background noise. Hey, don't confuse that I'm writing this. Notice I'm putting big freaking quotes around it. So it's like how many degrees? How about remember that? Reference angle is how many degrees back to the x-axis. How many degrees or radians to the x-axis? It's just how many degrees. Let's go here. We're at 225. How many degrees to get back to the x-axis? No, we don't deal. No, the nice thing, we're going to leave this. Reference angles are between 0 and 90 degrees. But this is a technical. Again, misspeaking, but for the nature of solving trigonometry, I might be a little bit off technically. But this is the way that I teach it, and the way I'm going to keep my little alpha in the game we're going to play. I want to throw the equal sign in there. Because actually the definition of the reference angle needs to be acute, and acute is less than 90 degrees. But for our intents and purposes, I'm just going to keep it with the equal sign. And we're also going to write it in like this. And let's just go off of this rule. And I got a worksheet we're going to go run through. I bet you anything you're going to catch the pattern. I've watched students for the last couple of years go through and do this, and they seem to get it pretty well. A couple bumps in the road. I usually do a whole group thing with this. I put you all into groups, give you the worksheet, and have you all figure that shit out yourself. So How far was it back? I probably got sidetracked. What is it from 225 to 180? Because everything's always going to be positive. We're going to be like, bruh, 45 degrees. Because the difference between 225 and 180 is 45 degrees. And when I say difference, it's just the absolute value with these. You know what I mean? Like even if you did 180 minus 225, you're still saying it's just 45 back. Cool? All right, let's go here. So this would have been our reference angle for theta being 225. And for theta being 150 degrees, we would say our reference angle is 30 degrees. Go! And now we go down to this next one. We're like 300. Now how far back to the x-axis? The shortest distance. Don't go back this way. That's too far. We want to be lazy. How far is it to go this way? How far is it from 300 to 360? How far from 300 to 360? 60, right? But if we notice, if you do this game anywhere, look at a 30 degree. Look at the 30 degree. Look at the 45. Look at the 45. 60, 60. What we're trying to do, let's think about the word reference angle, is we just want to be able to refer back to the first quadrant. We just want to think about what's going on in the first quadrant. Because if we could just memorize a couple things in the first quadrant, we could use logic that's going to solve for any quadrant. Let me just give you a little preview as to what I mean here. Let's take this out. Whether you make a right triangle at 150 or you make it at 30, well, probably not the scale. If I was to flip this side over just across the axis, imagine we're going across the axis and we're going to bring it around that way. Aren't they the same triangle? In theory, of course, my scale's probably off. They're the same thing. The only difference might be maybe this is going to be maybe. This is coming out of nowhere, by the way. You're not supposed to understand where this is. I'm just rambling on at you. 1 and negative root 3, and this one could be 2. Well, that would mean that this is positive root 3, 1, and 2. We're going to basically just use similar triangles, or actually the same frickin' triangle, except we're throwing some positive and negatives on some shit. We're going to use these reference angles to be able to solve anything. So don't short yourself. I'm telling you, don't frickin' short yourself on these frickin' reference angles. You frickin' want to know how they work, because it's going to make, instead of memorizing or just only being able to solve a trigonometric function when you have a calculator in your hand, I'm telling you, you're going to go back to campus. You're not going to have a calculator with some of your teachers. All right. Dude, we can do the same thing with radians. We can do the same thing with radians, except this is a better game. And this is where radians are going to become far superior. There we go. Theta is equal to 3 pi over 4. Let's go find its reference angle. So there's 3 pi over 4. I'm like, okay, how far is it from 3 pi over 4 to 180? Oh, I mean pi. Now we just go back to whatever angle we had, and we're like, okay, it's 4 over 4. Hey, isn't that the same thing? That's the same thing. 4 pi over 4 is the same exact thing as pi. We've just created a common denominator. So when you create common denominators, always go for these. Turn these into whatever you're messing with. You got a pi over 6, turn it into 6 pi over 6. You got a pi over 4, turn it into 4 pi over 4. So how far is it from 3 pi over 4 to 4 pi over 4? It's just 1 pi over 4. Huh. Oh, so the reference angle of 3 pi over 4 is pi over 4. Now watch this. We're going to play a game before I go to the rest. Angle is 17 pi over 4. You know what the reference angle is? Pi over 4. All right. The angle is negative 317 pi's over 4. Do you know what the reference angle is? Pi over 4. Reference angles are so much simpler when we're dealing with these common angles. Anytime you're dealing with a common angle, with a pi over 6, a pi over 4, a pi over 3, and it doesn't reduce, then your reference angle is just the pi over the denominator, whatever you're looking at. The reference angle of 7 pi over 4, how far back to the x-axis is this? How far back to the x-axis, the shortest distance to go from 7 pi over 4 to 8 pi over 4. Oops, I mean 2 pi. Let me change it for you. 8 pi over 4. Because isn't 8 divided by 4 equal to 2? So how far is it from 7 pi's over 4 to 8 pi's over 4? It's frickin' pi over 4. Dope. All right. 4 pi over 3. What do you think the reference angle might be? Let's see how far back it is. Okay, how far did we have to go? Oh, shoot. I don't like this denominators with 4. So let's get rid of that. Since we're talking about a 3, let's put a 3 and a 3 so we can wonder, how far back is it from 4 pi over 3 to 3 pi over 3? Yep, it's just pi over 3. All right. Now, what's the reference angle of pi over 3? It's itself. Okay? We don't need to find a reference angle in the first quadrant. That's the whole point. That's the whole game. So, here's your lead-in. We're going to move into this next. It's over here. Oh, there it is. This is going to be the next thing we do. We'll go into a worksheet in the next one. By the way, this is your quiz. It's your quiz for week 2. Is to turn this in. You're going to be able to find it under Worksheets and Test Prep. It'll be under Worksheets and Test Prep. Worksheets and Test Prep. This is due, oh my gosh, Wednesday, 11:59 p.m. if we're dealing in the summer. All right, see you.